All forms of iteration in Python do the same thing. For loops, list comprehensions, tuple unpacking, and iterable unpacking with an asterisk all rely on the same underlying mechanism for iterating over an iterable object. Let's prove that to ourselves by doing some weird things with dictionaries and strings. When you loop over a dictionary, you'll get the keys in that dictionary. If you loop over a dictionary in a list comprehension, you'll also get the keys. Iterable unpacking with an asterisk also relies on iteration. So if we use this to iterate over a dictionary, we again get the keys. The same thing happens if we use an asterisk to unpack a dictionary into a list. And even tuple unpacking relies on iteration. Anything you can loop over can be unpacked. Since we know there are 3 items in our dictionary, we could unpack it. And of course, as strange as it may seem, we get the keys in our dictionary when we unpack it. So what would happen if we turned our dictionary into a list by passing it to the list constructor? Well, list will loop over whatever iterable is given to it and make a new list out of it. And when we loop over a dictionary, what do we get? The keys. And of course, if we ask whether something is in a dictionary, we are asking about the keys. Iterating over a dictionary object in Python will give you keys, no matter what Python feature you're using to do that iteration. All forms of iteration do the same thing in Python. Strings are also iterables. So, what do we get when we loop over strings? Characters. The string join method accepts an iterable of strings and joins them together. So, when we pass a list to the join method, it'll make a new string out of that list. But what would happen if we passed a string to the join method instead? Well, join will iterate over that string. When we loop over a string, we get strings that represent each individual character. The string join method is fine with that. It'll happily join those characters together. This is weird, but it's really just Python happily iterating over whatever iterable we give to it. All iteration is the same in Python. That means that strings work with tuple unpacking. Here's the first character of our string, and here's the other characters. And we can even pass a list of 2-character strings to the built-in dict constructor, which will happily accept an iterable of key-value pairs to make a new dictionary out of it. This bizarre expression works for the same reason that this much less bizarre expression works. The dict constructor is expecting an iterable of 2-item iterables to make into a dictionary, and that's what we gave it. In Python, we love duck typing. The type of an object is often far less important than the behavior that that object supports. If an object quacks like a duck, it may be used as if it's a duck. Quacking is quacking, and when it comes to iterables, looping is looping. If we're performing an operation that requires an iterable, and we supply an iterable, Python will happily iterate. The type of iterable often doesn't matter. Now, this embrace of duck typing in Python does have downsides. For example, we might sometimes pass in the wrong object, and instead of our code raising an exception, something very weird might happen. But the upside of duck typing is that it's often very easy to write code that was designed for one type of object, but works just as well with many other types of objects. For example, you may think of sum as a function that's designed to accept a list of numbers. But it also works just as well with any other type of iterable, whether a set, a tuple, a generator, or anything you can iterate over to get numbers. So the next time you use any form of iteration in Python, remember that under the hood, all iteration does the same thing.